Hi, welcome to this video. In today's video, I'm going to look at a very interesting sum. We have sum of 1 over n squared as n goes from 1 to infinity. We previously evaluated this sum by using, but today we are going to evaluate the same sum with using different method. It's called Euler series or Maclaurin series, okay? And combined with the Euler series as well, okay? So now, as you know, we have f of x set. If you want to know about the Euler series, just go to the previous video. You will see all the details. So we have sine x equal to x minus x cubed over 3 factorial, okay, plus x to the 5 over 5 factorial plus and so on and all the way down, okay? It's called Maclaurin series or Euler series, okay? So what I'm going to do now, I'm going to divide by x. So I will have sine x over x is giving me 1 minus x squared over 3 factorial plus x to the 4th over 5 factorial and all the way down, okay? So also, if you take a look, we have this function, this sine function, it looks like this one. So the roots of this function, sine x, we have 0, we have pi, we have 2 pi, and so on. In the negative area, we have minus pi, minus 2 pi, and so on, okay? If you take f of x, if you take x squared minus 3x as an example, okay? So the roots of this function, x multiplied by x minus 3, so the roots are 0 and 3, for example, right? If you plug number 0, if you plug a 0 into this function, it's giving you 0 because the 0 is a root of this function, okay? The same thing with the number 3. If you plug number 3 into this function, it's giving you 0 because the 3 the 3 is a root of this function. So 0 and 3 are the roots of this function. The same thing with the sine. We have the roots minus pi, we have the roots of this sine x, 0, pi, 2 pi, minus 2 pi. So the same thing with sine x. We have sine x equal to x multiplied by 1 minus x over pi multiplied by 1 plus x over pi multiplied by 1 minus x over 2 pi multiplied by 1 plus x over 2 pi and so on, all the way down. 0 and pi and minus pi, 2 pi minus 2 pi and so on are the roots of the sine x, okay? Why I'm doing this on this form? Because if you plug the number 0 here, is giving you 0, that means 0 is a root of the sine x. If you plug pi this in this function, let's take the x equal to pi. This factorization is making a lot of confusion for many people though, because you see the f of x is written differently. This one is written a little bit different than this one, okay? Because this one is written as x multiplied by x minus 3. This is written as 1 minus x over pi multiplied by 1 plus x over pi. A lot of people are asking why this one is written on this form. Because this one, when you plug number 0, is giving you 0 because 0 is a root of this one. 3 is a root of this one because you plug in 3 into this function, give you 0. The same thing here. If you plug pi here, 1 minus, if you plug the pi into x, is giving you pi over pi, which is 1. 1 minus 1 equal to 0. That means pi is a root of this function, okay? The same thing with minus pi. If you plug the minus pi here, it's giving you 1 minus 1 equal to 0. So the minus pi is a root of this one. Same thing with 2 pi and minus 2 pi and so on, okay? So that's the reason why this is written on this form, okay? So let's move on to the question, okay? I'm going to make the combination or relationship between Euler series and Euler series. This is Euler series. This is Maclaurin series, okay? So as you see here, because the sine x, we have sine x. I'm going to divide this one by x. We'll have sine x over x equal to, what I'm going to do now, I'm going to multiply this one by this one. It's giving you x squared, x over pi squared. This is written on the form a minus b multiplied by a plus b equal to a squared minus b squared. The same thing here. So this one is multiplied 1 minus x over 2 pi squared and 1 minus x over 3 pi squared and so on, all the way down. Okay? Now, if you take a look at here, this function equal to this one as the same. What I'm going to do now, I'm going to transfer this product into sum. Okay? So this one, I will have, if you multiply number 1 all the way down by 1 is giving you 1. 1, 1, 1. Okay? All the way down. So it's giving you 1. If I'm multiplying this one, it's giving you minus x over pi squared. Okay? This one is going to be multiplied all the way down by 1, 1, 1, 1. Okay, it's giving you the same number because it's multiplied by 1. Okay? Also, if I multiplied this one by 1, okay, I finish with the 1. I'm going to multiply this one, the second one, by 1 and all the way down. Okay, it's giving you minus x over 2 pi squared. Okay, so minus the third one is multiplied by 1 as well. So I will have minus x over 3 pi quinary square. The fourth one, they will be multiplied by number 1. It's giving you x, the 1 all the way down. That's mean if you multiply something by 1 n times, it's giving you the same number. Okay? The same thing what happened here. This is what happened here. So x over 4 pi square and all the way down. Okay? I don't care about other numbers because I don't need them. I need only this term. I need only this sum. Okay? So now I'm going to multiply by x squared and pi squared in the same time. X squared over pi squared. Okay? With minus sign outside. So I will have, this one is multiplied by 1. This one is multiplied by 1 over 2 squared. The third one is multiplied by 1 over 2 to the 3. The fourth one is multiplied by 1 over 2 to the fourth and all the way down. Okay? This one is called 1 minus x squared over pi squared. This one is the sum of 1 over 2 to the n as n goes from 1 to infinity. Okay? So now this sum, so this is the sign x over x. Okay? Now I'm going, so we were at this expression. We have same function is written on two different forms. Okay? The first equation is written on the form of Taylor expansion, which is 1 minus x to the x squared over 3 factorial plus x to the fourth over 5 factorial and so on. The same function is written on this form, so the sine x over x equal to 1 minus x squared over pi squared multiplied by this sum. Okay? Now I'm going to make the combination between terms. If you take a look at the first equation, you will see x to x squared over 3 factorial. If you take a look at underneath equation, okay, you will see minus x squared over pi squared multiplied by this sum. Okay? So this means minus 1 over 3 factorial equal to minus 1 over pi squared multiplied by this sum. Okay? By matching the terms. Okay? So now I'm going to, now this implies minus 1 over 3 factorial equal to, so minus 1 over 3 factorial equal to this. So minus 1 over 3 factorial equal to 1 over pi squared multiplied by this sum. This sum is the sum of 1 over n squared as n goes from 1 to plus infinity. Okay, so now I have minus sign. I'm going to cancel out. What I'm going to do now, I'm going to multiply by minus pi. I'm going to multiply minus pi square on both sides. Okay, so I will have pi square over 3 factorial equal to this sum, 1 over n square as n goes from 1 to plus infinity. So 3 factorial equal to 6. Okay, so this one. So now this sum, what I'm looking for, 1 over n square as n goes from 1 to plus infinity equal to pi square over 6. So now the sum is evaluated. Okay, so I have done with this problem. Thank you for watching. I will see you in next video. Bye.